Yo, it's the Codeforces Round. Pog. Uh, Starts in 14 seconds. See how I do. Yeah. Oh, nice Monday morning to start. Yeah, let's go. Given an array with a non-empty sequence, whether it has a non-empty subsequence such that the product of its elements is not a perfect square. Just check to see if an element is not a perfect square or not. Is it just yes or no? Yeah, okay. Everything is up to 10 to the 4, so... And then over here, it's... should be yes and no. Okay. Problem B is next. Let's see. T, N, and K. First word through and 0 is some big. Given two integers, N and K, count number of arrays such that between this and this. Well, that happens when all, like for each bit, exactly one of the numbers is set to be 0. So it's pretty much just like how many ways, for each bit, how many ways can we assign that digit. So if we have n and then integer.parseInt st.next token, let's see. One, two, three, four, five, six, seven, eight, nine. Okay. Yeah, so everything between 0 and 2 to the k. So that means there's k like bits. And for each of these k bits, we want to know how many. Yeah, it's just res times n. Okay. Nice. Okay, so A and B so far. Let's see. Problem C. Only one number. Given an integer n, find the longest subsequence of this whose product is 1 mod n. Product is 1 mod n. N is not necessarily prime or anything, so that's interesting. Oh, we print the subsequence. Oh, okay, I see. Let me think about this one. Let's see. Okay, what if the whole thing is 1 mod n? So 1 is an element that we can always include. Its product is 1 mod n. That pretty much means it's a multiple of n plus 1. Yeah, so in other words, we want to find the longest sequence such that it's a multiple of n plus 1. Is that correct? So sequence of 9. Oh wait, that's not necessarily correct though. Is it though? Wait, 3 times 5 times 7 is... That's not divisible by 9. Yeah, but... 104 is apparently divisible by 8. Is it like that plus 1? Oh wait, no, not necessarily. Yeah. Yeah, that's not necessarily true. Let's see. Okay, well the only input is n. And we definitely need to know. Split into n is even or odd? Maybe. Okay, what if n was 6, for example? If n was 6, then those numbers are already... Oh, okay. Wait, that also means that if it's like that plus 1, that means it also has to be like a prime factor plus 1. How do we force that? Wait a minute. When we take this number and then multiply it, if we take like a subsequence and multiply it by n on both sides, we pretty much get like the entire subsequence mod 0. Well, does that help us at all? So we have 1s and we want to contribute some elements such that the product of each other is also 1. So if we turn this into a graph, maybe we can turn this into a graph and then it's like the longest path in some sort of, or like something like that. Because we can only go from one number to the next. Yeah, if it's like some sort of product. So 2 times 3 mod 6 is 5. This is 10. What is that? 105. Yeah. 105 mod 8 is this. Longest subsequence of this. Because if we have a 1, splitting it into 2 and then 3, do that. Alright. We want to make this equal to... You can make it into a 9. You can also make it into 17. Wait, if we make it to 9 or 17 or... 17 is a prime number, and then after we get a prime number, it's like another number after it. And so we have like some numbers that we have to keep. Okay, so if we split everything into prime factors, we can then just figure out a way to is there a way we can reassign these prime factors? Product of an empty subset. Well, okay, when n is even, that condition has to hold. Did we just do that factor? Okay, what do we do once we decompose into prime factors? So find prime factorization. What do we do after that? Yeah, so like for each list of primes, we could take like 1 and then 2, or and then like another value or something like that. Does that seem right? I don't know. Because if we have like a 1 and then one of each of those prime factors, and we take like a product of those prime factors, this doesn't work because it can be very large. Maybe it's just like you include all elements that aren't a prime factor, that don't have a GCD with it, or like have a GCD equal to 1. Okay, let's try that, and then see if it works. No, not quite. Because if we have a 2 and then a 4, if we to be. So 1 and then. Because if it's prime, then it's like not divisible. Otherwise, it is divisible. Let's see what the product. Okay, so if let's say n is odd, n is even. Say if n is equal to 4, then you would have to choose from 1 times 2 times 3. Yeah, wait, so if we, because if in this number, let's say if n is divisible by 2, or like it's divisible by a, if the product that we choose is also divisible by a, then their GCD is a multiple of a, so we can only choose relatively prime numbers. Problem is that it doesn't necessarily guarantee it's going to work. Yeah, so like this is a necessary condition. Okay, so yeah. That's definitely like true. What about like 1, 2, and 4? Wait, what about 1 times 3 times 4? 12. No, it has to be prime because if it's... No, does it? I don't think it does. Because it's like 1 times 2 times 3 is this. Okay, so if we take this number and then it's going to be this mod this. So if we remove some like small prime number, then it can divide it. Yeah, so if it's 5 mod 2 or 3, 2. 2 goes into 2 twice. So it's like, okay. Do we just guess forces? I might just guess forces here. 7. 1, 2, 3, 5. Is that correct? 2 times 3 times 5 is equal to 30. Nope, that is not correct. Okay. What is a largest sequence then? So it's 1 through 6 that we get to choose from. So 720, we want to find something divisible by 7. What if we get rid of this number? 20 mod 7. What about 720 mod 7? It's 6. Oh, wait a minute. Am I dumb? We just like take, okay, what is the product of 1 through 7? Mod 8. That's 0. Okay, so we take GCDs that have to be equal to 0, and then we can remove them. Oh, okay, I think that's how you do this. Yeah, I think this works. Let's not have V. So long mod is equal to 1L. Mod times V mod N. So if mod is greater than 1, so 5 is 3, 8 is that, 7 should be this, I think. I mean, that's at least a right value. How about 3 is just 1? 4 is just itself. Yeah, it's just submit. Oh fuck, it doesn't have to be prime. Fuck. Oh my god. Jesus Christ. Oh, I'm so dumb. I'm actually dumb. It does not have to be prime. Jeez. Sheesh, dude. Oh, that was so dumb. Yeah, okay. I should not have gotten that wrong answer. Oh, god dang it. That also took way too long. Whatever. Cut and slack. Let the grab pair of scissors and do the following to it. So NQ regular queries. He partitions the sequences into subsequences. Single partitioning is beautiful. If he thinks that partitioning is beautiful if for every subsequence, if it has a length x, it doesn't exceed that. Okay, so because we only care about that scared the fuck out of me. What the hell? Oh jeez. Okay. Sure. Okay, well, because for each subsequence we only care about the occurrence of elements, the order actually doesn't matter. The order only matters in terms of like the elements themselves that we pick. So what if we process these queries offline and then we keep like some sort of thing that keeps track of frequencies? So if we do something like, let's say one element appears once, one element appears once, one element appears like 4 times. Minimum number of subsequences we would have to split this into. Okay, if it's strictly more than this many times, if it's even, then, well, it's strictly more than 2 times, or if it's like 5. Okay, so we can actually have something appear 3 times, which is interesting. So in other words, if we can take a subsequence and rearrange it in such a way so that no 2 elements are, like, no 2 adjacent elements are equal, then it's valid. So okay, I think that's important. Is it? Okay. It might always be 1 or 2, come to think of it. Actually, no. I think it's more of like, for each number maybe, the number of times that it appears. If we can keep a frequency in the max. Okay, so we need to keep track of the maximum value. If the maximum value doesn't exceed this, otherwise if it's something like that. Okay, if it's something big where we have something like A, B, A, C, and then like 2 A's, I mean, we could put one of the A's over there, I guess, but let's say we have 2 A's over here. If we move an A into here to, then it would have to be like 2, like separate A's like this. Yeah, because then we would need an element from here, and like, that won't make our answer better in the first place. 1 to 6, yeah, and then 2 to 5. Because this appears once, we have one sequence there and another sequence there. Let's try this. I think this is correct. Now how are we going to do this? Okay, we need a segment tree to query the maximum value. Yeah, we need a segment tree. Maybe process queries offline. Yeah, I think offline queries are the way to go here. So we need So like we move this pointer, and then we move it out. Wait, but if we do something like this, we need to subtract the occurrences. Moz will definitely not run in time. Will it? Wait, let's see. Actually, I'm not sure. Do I want to risk it? Let's see. That might be able to run in time. Maybe I'm being optimistic here, but we'll see. Well, let me first think of a way to do this in a model. These queries offline, keep like a left boundary and then a right boundary. It's based on the frequency itself. But if it's based on frequency, then how do we figure this out? Wait. If we have something like this, and then we do some sort of segment tree stuff. Wait, yeah, Moz would probably be too slow because you would have to end root n, but on top of that, you would also have to have a log factor to update the seg tree. Maybe, okay, maybe we can do n root n by using a pointer. Because we have a value that like starts at something. Yeah, we can keep frequency. We can keep a frequency of like the largest value. Let's try this. Like, I don't think this. I think this was worth a shot. Fast scanner query. I just want to make it 0 indexed. Left. Okay, so how does Mo's work again? If left divided by square root. Oh, we need I for IDs. So vowels at the frequency of V gets increased by 1. So okay, so if there's some number that occurs V times, then large becomes V. Is equal to so this is a total number of elements, and then this is like large as like the element that appears the most number of times. Otherwise, we return k minus. Yeah, so it's like 5 minus. Wait, no, there's 7 elements in total. 1 plus k minus small plus 1 over 2. Or I guess no. Small plus 1. Is this k minus small 1? Because 7, there's no. The small itself is one group. Okay. Q is, okay, well. Int L is equal to QQ is 0 dot left. Dot right. One extend out the node. If left is equal to QQ at Q dot left, and right is equal to QQ at Q dot right, and at the very end we do res at QQ at Q dot ID is equal to get large. Okay, so while left is greater than, no, while L is strictly greater than left, and while R is strictly less than right, and this is while L is okay, those are the things that we do. So if we have instead of over 2, we can do left shift 1. That may be that's a little bit faster. Because if it was 8, then it's 4. Yeah, because we can't, we could do 8 and 5. If we do 5, 3, 5. No, we can't. Wait, can we? No, we would need 9 elements, yeah. Yeah, okay. And small is equal to n minus k, so we want to return k minus small minus 1. Because then there's 2 left, so it's just k minus small. Small in this case is 2, k is 5 we can take care of. Is k minus small minus 1? Yeah, because this is number of k's left is equal. For every small, we get rid of a k, and then we get rid of one more. And so, k minus small minus 1, but then we plus 1 because there's an extra sequence. Yeah. Wait, so that's literally the same as, whatever. Yeah, it's fine. So while this val is equal to array L, wait, no, we want to update it first. And so, wait, no, frequency. The vowels of, okay, well, in f is equal to the frequency of this. So if large is strictly queries? I did. Okay. Vowels at f minus 1. Vowels at f. If large is less than f, large is equal to f. Yeah, because now vowels becomes a 0. Okay, this one might be a little bit trickier because okay, then frequency at array at L minus frequency at array at fuck. It's vowels at f minus 1 plus plus, vowels at f minus minus. So if the vowels at large is equal to 0, then large decreases by 1. Yeah. And if vowels at large become 0, then large goes down by 1. 1, 2. Okay, I use fast scanner. Let me make sure I do I am doing Mo's correctly. I'm pretty sure I am, but it should not hurt to check. So all queries with L values. So let's sort. Yeah, that seems right. Do we just submit this? I'm gonna submit it. Okay, that was actually pretty fast. Well, we take those. Alright, problem E. EHAB's last bullshit. N rooms or room from A to B but never both. Okay, so it's a tournament graph. Baby Ehab wants to go play with Baby Badawi. He wants to know if he can get to him. However, he doesn't know anything about his apartment except number of rooms. He can ask the babysitter 2 types of questions. Is the passage between room A and B directed from A to B or the other way around? Does room X have a passage towards any of the rooms here to here? Wait, so what's our output? The case character. The ice character of the ice string. test cases. Sum of n won't exceed 500. Okay, so n cubed is fine. We ought to go play. Room X has a passage. So does it mean room X? Can you go from room X to any of these rooms? Is probably what it's asking. Huh. That's interesting. One if it's from A to B, 0 from B to A. 2 xk, okay. We'll answer with 1 if there's a passage from X to any of these rooms. But we don't know which room it is, though. Alright. Is there a lot of interaction? Okay, so what if we instead, for queries of second type, we ask just like one other city? More certainty this way. Yeah, but if you were to do that, it might be hard to keep track of how it changes. How many solves? E doesn't have any solves yet? Oh my god. That's kind of scary. I'm debating whether I should spend some time trying to hack people or not. Because there is a hack on A right now. If not square x, res is equal to yes, otherwise we do this. That's 100,000. If this is strictly greater than 10,000, then wait, the bound is 10,000, right? Yeah. So if x is not a perfect square, then it works. I want to lock it. If element is not a perfect square, because obviously if all of them aren't, if the whole product isn't a perfect square, then one of these numbers have to be offset. So. want to see if there's is there a solution? Because I have a feeling that the hacks might be because of like the fact that people are using doubles. But at the same time, I don't like those type of problems. They're just kind of difficult to hack in the first place. Especially since it's only 10 to the 4. Yeah, I'll just... Let me think about it a little bit more. K is false. Wait, hold on. This is for every n. And then it's like for every n in here, for every n in here, s is equal to this times this. N is at most 100. If n is at most 100, then I'm not sure if... Okay. Then it's 100 times 100. Oh, wait. Hold on. It's saying it's going to at most n, but what if there's some large number? Okay, I think I can hack this. Let me first type it in custom inbox, because I don't have C++. But I believe we can hack this. You know what? I'll show it on here. So this is the solution that I want to hack right now. I have to type it up first though. Include bit stdc++.h. What language is this? G++11. Define LL as long. Using namespace xtd. LLT a at 105. N and S. And then we do bool OK is equal to true. Bool KT LLN. LLTAN is equal to square root at N. Return tan times tan is equal to N. Main, and then we do the iOS stuff. Sync with stdio at 0. Cout.tie at 0. cn.tie at 0. So while t minus minus. cn a at I, and then for each value, for int k is equal to I plus 1. Oh, wait, hold on. Oh wait, yeah, I think I can still hack this. Yeah. So if I do s equals ai times a at j, if kt at s is equal to false, then cout is equal to yes, a new line, and then OK is equal to true, then we break. And then down here, if OK is equal to true, then we break. Why wouldn't you not just do if true, but whatever. I have to copy this word by word anyway. If okay is equal to false, like this. Okay, so let's first test it on sample. Okay, it works on sample. Now I'm gonna test it on the case which I believe should break this. 7, 28. It says no, but my code prints yes. Because the non-empty subsequence is that. Okay, I'm gonna try to hack it. So this is a test case that I'm using. Yeah, because it's checking if every pair is a perfect square or not. Okay, nice. How many points did +1 pog? Okay, so that was a successful hack. Let's see if there's any other successful hacks we can do. I mean, I feel like double precision might be a valid hack, but I don't know if I want to spend time like trying to figure that out. What on earth is going on here? Yeah, it's just double precision again. What is check? Or just potentially double precision? I feel like because the numbers are so small, double precision isn't actually an issue. 10 times. Okay, this is how you should be doing it. This is actually like perfect. That's actually like the best way to do it. Is perfect square. If is prime does not equal to 1. Or I mean, well, it should be is perfect square, but other than that, it looks fine. Check, that seems really weird. Do I want to try to hack this? If a ceiling is equal to the floor. I feel like this is double precision. I'm not gonna try that for now. If okay is equal to 1. Okay, that looks fine. Okay, that's fine. Clee. Oh, you play Genshin Impact. Huge. Is your profile picture Clee? Hey, I approve. I approve. You know what? I'm gonna friend you for being cultured. ZZ is equal square root of I if it doesn't equal. Okay, if it does not equal to this. Wait, okay, so. What the hell is this? Wait, what? If ZZ. Oh, they're taking a square root. If it's not equal. That doesn't seem right at all. Wait, and then like this loop is just doing and then this loop was the same like reason I was able to hack the one before. Wait, what is this code? What the fuck? I don't even know what this is doing. I'm gonna try to hack it. Include bits.stdc using namespace yes and no? How you do? Okay, I'll copy the define statements that are like, that he actually uses. Let's see. Custom test. Main iOS sync with stdio false. cn.tie null pointer. cn while t minus minus. Wait, you can do that in C++? I did not know that. What the hell? I thought that was illegal. Well, I mean, to be fair, I don't know C++ very well. Hence why I code in Java. And you know what? That is completely okay, because we don't judge anyone based on what language they use, unless if that language is Python. So if ZZ times ZZ is not equal to, and ZZ plus 1, and then f is equal to 1, or int j is equal to I plus 1, j is less than. LLP is equal to LL x at I times x at j. LLZ is equal to square root p. So if z times z is equal to p, or z plus 1 times z plus 1 is equal to p, then we continue. Otherwise, f is equal to 1. And then if f yes, else no. LL is long. What? Oh, there's no semicolon. Like, I don't know what this code is doing. Because it takes a square root, and then it sets it equal to true. If, like... Wait, what if we just do, like, 1117? Will that break it? No. Oh, if it doesn't... Oh, okay, I understand how this works now. Oh, okay. Okay, you know what? Yeah. Okay, I understand. I think it should be fine then. If TPS... Yeah, that's fine. That's definitely fine. Square root, that's honestly fine as well. Okay, I think that's probably all of the hacks I can get for now. How are we doing in rankings? We're 14th in Div 2 right now. That's pretty good. Okay, there's also an E, so I think I'll think about E a little bit then. Yeah, I think we'll go back to E for now. Let me just pull up IntelliJ. Yeah. still an hour left. Let's see. Oh, that's annoying. I have to, if I want to hack people, I have to turn off dark mode. Whatever. Let me think about E a little bit. Nine and 2. What's so special about 9 and 2? Okay, because we can query. Yeah, I mean, obviously we can't use exclusively queries of a first type, because we would need to use like n squared of them. But how can we determine information if we know like some paths already? Okay, so there's a path from A to B. Okay, if we query that there's a path from A to B, one thing we know for sure is that there's an edge coming out of node A and coming into node B. We just don't know if it's like a direct edge or if it's like indirect or whatever. I'm not gonna lie, I want to spend more time hacking. Like, hacking is kind of fun. Has anyone in Div 2 solved E yet? Oh, Rainboy. Well, I mean, he doesn't count. Let's see. Two N queries. Query of type 1 and type 2. Yeah, I mean, it's more useful if we... Can we somehow reduce this into a problem where we need to basically figure out whether a node cannot reach any set of nodes? Because that's what the second query is good for. It's not really good for like telling you which node is it like reachable to. Okay, if we can query all of those and like some other of the same thing. and it's kind of unclear as to how it could work. Yeah, this problem seems really hard. And I mean, given how an hour, like almost an hour and a half has passed, and there's only 3 solves overall, I don't know if I can get this. It seems pretty difficult. What I can potentially get are more hacks, so I'm gonna I wanna look for more hacks. Although let me see. Hacked, apply. There's one hack on D. Okay, that's kind of scary. Yeah, hack on D is scary. Yeah, that's kind of concerning. Everything else is on A though. Could my D get hacked? I mean, if I had to guess, it might be because of maybe if you use C++ and there's like this overhead with a segment tree. I feel like that might be a reason why. Yeah, but I think because I use like this pointer to kind of keep track of the maximum, it's n root n. And I don't think there's any. Is there a better way to figure out the mode? Probably. I feel like there isn't. Because like this is just over 10 to the 8 operations maximum, which given 3 seconds, I think is okay. Yeah, I'm not really sure how I would try to fix that. Yeah, so we change it first, then we update, and then we remove it. No, yeah, we remove it and then we update it over here. This is just the get function. Yeah, I think it's fine. I don't know if I should worry about it. Let's see. Are there any new potential victims for A? There's one. It looks fine. Yeah, it actually looks really good. I want to think about E a little bit more then. What if maybe it could be randomized. Actually, graph problem randomization. I don't know. Because maybe if it's like if a node is not reachable from a bunch of nodes, then it's likely to not. Well, I mean, that's not necessarily true either, though. Because we have a node that like goes to like some set of nodes, but then those nodes have like all edges incoming of like a next layer, then it's possible to break it like that. That's true. Wait, alternatively, okay, wait. If we answer x in a set of S and we get a 0, if x can't reach. Okay, if A can't reach node B, does that mean B can always reach node A? That's an interesting question. If you can't go from, I mean, there obviously a cycle can exist, so just because you can go from A to B doesn't mean that B to A is blocked, but if you go from A to B, if A to B is blocked, is B to A guaranteed to be open? Like if from here to here, okay, if we can go from 2 to 0, which we can't in this case, well, actually no, we can. Okay, what if this edge was direct out here, which means we can't go to 2 to 0, but we can go from 0 to 2. Oh wait, yeah, isn't there an edge between every pair of things? It's either direct passage from B to A to B to A. Yeah, okay, so edge has to go from, then this has to be a thing. So if we picked like a random node, and this random node has like some number is going into it. Then maybe it could work. Let's see. Is there anything I could potentially hack? I'll look through them again. Temp. Okay, so I believe this step over here isn't even necessary. So if you have 1, 1, and like this. What about -1? What is problem B again? Is there a way to hack problem B? I kind of doubt it. What if we do this? Like, I'll do 2, 1, 1. Like that. No and no. Okay, I'll just think about problem E more. Yeah, I want to set, yeah, I'll do that. I'm gonna spend, okay. Yeah, I'm gonna leave like the last 10 minutes to like try to get more hacks. Let's see, other than that, we have this. Babysitter 2 types of questions. Okay, so we know that if going from A to B is impossible, then edges have to go from B to A. Yeah, so asking, so like if we can ask these queries correctly, then we can like determine a bunch of edges at once. Okay, we have 11 queries in total. Oh, I guess 9 n queries. So n squared minus 9. Well, okay. 100 squared minus 900 is equal to 9,100. 9,100 log base 2 is about, well, it's 2 to the power of 13, I think, about, yeah, or 14. So if we can do some sort of binary search, like maybe for every node it's like 100 and we do 14 of them, and it's like 14, 1,400. Then but then, well, how do we binary search the size of the set in the first place? Yeah, maybe with randomization? Because we obviously shouldn't be querying the whole thing at once. So maybe instead what we can do is if we know with some certainty that path from node A. And the path from node B exists. Oh, there's a hack on B. Okay, that's all I needed to see. I think we're gonna lock B then as well. That's, bro. I swear, if that somehow gets the wrong answer, I'm like gonna riot. Cause the answer is literally just n to the power of k. I am using a for loop to iterate over it, but there's only 10 test cases. It should definitely be fine. There's no way this TLEs like to the power of 5, and it's only like to the power of 20 at most as well. Yeah, if k is equal to 1, then this is 1 bit, and there's exactly n ways to assign that bit. Yep, okay. Problem B, let's see. Mod power. Yeah, that's fine. Well, how slow is that going to be? Like, how fast or how slow is that going to be? Let me check. Let me use custom inbox first. I mean, I feel like it's probably not super slow, but if it's to the power of 20, it's like 2 power of 5, 2 power of 20, it's like 100 digits. Yeah, I feel like it's probably not that big of a deal. But I think it's probably worth trying. Like, I'm just grabbing at air. T equals input. And k is equal to map. Input dot split. Print. Okay. So this is Python 3.9. He did not submit in PyPy. He submitted in Python, which is pretty interesting. Right? Yeah, I submitted in Python. So what if we did 10? So we did 100,020. So we did that once, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that was really fast. Yeah, we're probably not gonna break that. Power mod, that's fine. Clee. Is F a long? Yeah, that's fine. Answer, LL answer. Answer times n mod that. Yeah, that's fine. BP. Yeah, none of those look like... I don't think I can hack any of those. God, I wish there were more, like, breakable solutions in my room. Ugh. I can only hack one. It's fine. Let's see, problem E. Okay, so if it's going from A to B, as we go from B to A, if we ask a query, that goes in some direction. Wait, if there's like, what if there's like a node in which all of these have like a really high in degree? It's like this one has like a really large in degree like this. And then this one is like, goes like this. This one goes like this, and this one goes like that. Even if it's like something really weird like this, if we do randomization, it's still likely to find... Okay, yeah. Okay, so if we randomize this, and then we like do some sort of a binary search type thing, where we can query up to n, like, up to n of those nodes. Wait, so is it possible to go from x to those? I'm just, because given how there's only one solve in div 2 for problem E, I don't know if it's worth my time. It might be more worth my time just trying to get one more hack. Yeah, I think I'm going to do that. Did he define? Okay, he defined as long. Yeah. Is there a way I could hack this one? Custom test. Let's see. Tez is equal to input set while. Okay. Let's see. List map. So if j to the power 0.5 does not equal to 0, then we break. Else c plus equal to 1. If c is equal to num, then print no, else print yes. One, 3, 7, 7, 7. I don't know. Oh. Let's see. Input dot int. Oh. Wow, I really don't know Python, huh? Okay, what if I do like 1, 2, 9801, 19802. Arias, wait. No, that's supposed to be 1. This is supposed to be 2. There should be no, then yes. Okay. Yeah, I don't know if that's helping at all. Long. 1, 2, 3, 4, 5, 6, 7, 8, 9. We need to get just one more hack. I don't, dude. I'm just like waiting for people to submit in my room, so that I can just like try to hack them. Cause I just need one more, like one more hack. Should be enough to guarantee me 2200. But right now I'm 2199. Bro, just one more hack, dude. Just give me one more. Okay, I'll think about E a little bit more. Let's see. Okay, so for a query, or not for a query, but if it's impossible, if it going from A to B is impossible, edges must go from B to A. That's true. So if we query some form of sets, right, because out of the nodes that we like, well, out of node X, it's going to return 0 if it's like, if everything goes into X. Okay, so if we pick a random node, okay, picking a random node should give like equal-ish probability. So if we do one pass, if we, no, but then it's like, it's random, so. Okay, let's say we processed like all but 2 of these nodes. Then we just need to use a query to determine if it's reachable from here to here. I have a suspicion that the hack on D is TLE, where people may have been using sectree or something. Let's see. Okay, who implemented it in the most suspicious way? if A, what is R? Wait, this guy uses floats. Isn't that like worse than doubles? Let's see. If I get rid of this. This is G++ 14. So include IO stream. Include bits. TIJKN. And then float R. And F is equal to 0, C and a T. C and A to J, so 4J square root F A to J. F++ when you break out of this loop. Okay, so for F equals N. Yeah. Okay, so 2 test cases, I'll do 1. Actually, I'll do 3 test cases. Wait. Wait. Hackable? Is this hackable? Oh wait, shoot, I almost, no. F equals 0. Yeah, that's why. Whew. Okay. No, yes. Hmm. 9081, and then like 9802. I don't know if I could hack this. And that's not a big deal. That's fine. Any more? No. There are unfortunately no more. Just give me one more hack and I will be happy. Wait, he uses integer root. But I guess if it's an integer, then... Yeah, I don't know. Int square root of f. Including IO string. Okay, what if I do PS at I, or if this and f is true. Yeah, that's definitely fine. Okay, which problems have hacks now? I mean, it's just all mostly A. I have no idea what this could be. Like, I have no clue. Like, why are there hacks on B? Did I, like, forget an edge case? But then if I forgot an edge case, like, my entire room would FST it. Yeah, I have no idea. Long, yeah, that's fine. Is okay a long? It is. That doesn't have to be a long. Yo, this is kind of weird, though. I'll look at the other rooms out of curiosity. This guy got hacked. As well as this one. Yo, unlucky. I just need just one more, dude. One more. I'm gonna... Okay, what about you? That's probably fine. This seems kind of suspicious, but I feel like it's probably fine. Like, what's the square root of 9802? Yeah, that's big enough. That's probably big enough. Dude, just one more hack, dude. Come on. This is so funny. This is so funny. Integer? Wait. Oh no, long int. Yeah, I already checked that. Define int as long int. Bro, people need to be... Why is everyone in my room so smart? Dude, my room is like too good. They're like... There's like none of the stupid mistakes. Either that or the pretests are just relatively strong for this problem. Wait, but K is only 20. Modding it won't even make a difference. Yeah, I don't know. F equals F times N mod X. Long, yeah, that's... Yeah. Constant int mod. Does this need casting of any sort? No, I don't. No, it doesn't. Okay, I think this is probably just going to be my contest. I couldn't get the one hack that I needed, but it's okay. At least I got one in the first place. That's something to be happy about. 23rd right now. Should I? Maybe I should have spent time thinking about E. Maybe I should have. I don't know. I'm not gonna think about it too much because if I do and then I find out that it's like not that hard, I'm gonna be kind of disappointed. I hate how I got a wrong answer on this. Dude, that might actually cost me 2,200. Like, just... Because I had this line over here, because I was, like, just trying to figure out, like, a pattern, and I forgot to remove it. And the worst part is, like, I realized that it was wrong, like, before it gave me a verdict. So, like, I, like, corrected it immediately, and it worked. Yeah. That really sucks. Also, it really sucks that this is 2 hours 15 minutes, bro. If there were 15 less minutes, I probably would be 2,200. Whatever. What am I predicted right now? God. I am predicted 2189. Okay. Very cool. Okay, wait. Successful hacking attempts on A. I mean, all these are going to be A, aren't they? Yeah. This guy got 7. Jesus Christ. There's 1 on B. What language is this? What language is this person using? He's using C++, and he did correct it. I don't know, man. It's weird. I mean, okay. If we're being optimistic here, if we don't FST and like 1 or 2 people FST above us, then that might be enough for 2,200. I don't know, dude. Oh, God, I'm kind of tilted because no one is submitting, and I'm pretty sure I can't hack any of these Bs. I don't think I can hack any of these As. If one of these do FST, I don't think I would have caught it because they're just like double precision. And I don't know like C++ well enough to like understand how memory works. Alright, still. I'm just gonna refresh this page until I see someone like make a new submission, which I don't think anyone is doing. Oh, wait, you got D. Nice. Yeah, okay. I'm gonna go over solutions really quickly. So, yeah, I'll just do that. Problem A. Problem A, pretty much, because of how, like square free numbers work, if there's a subsequence that exists that has a product of like, that's not a perfect square, then one of its elements has to not be a perfect square. So you just check to see if any of these numbers is not a perfect square, and if at least one number is just, the answer is yes. Pretty straightforward. Let's see, problem B. Okay, so for problem B, pretty much the only thing that you care about is for each bit from like 0 to k, the kth bit has to have n minus 1 ones and exactly 1 0, because that's how you can maximize the sum. And so pretty much you're gonna have a set of, you're gonna have 1 0 and n minus 1 ones, and you want to find out how many ways you can put the 0 in any one of these positions. And because there's n indices in total, it's simply just n. So the answer is just n to the power of k, mod, like this mod, of course. Yeah, also pretty straightforward. Honestly, I thought B was like maybe a little bit easier than A, but actually no, they're about the same. Yeah, still pretty easy. Problem C got me stuck for a little bit. So pretty much, if you were to imagine having a set of numbers from 1 to n minus 1, you want to find the longest subsequence such that its product, mod n, is equal to 1. So with that like property, if that holds, basically what you can do is, if you think about how multiplication works, if it's impossible for a number A to B and a number B, well, okay, how do I phrase this? So if in the product that you choose, if the product has a factor that is a factor of n, then that means the GCD, or not the GCD, the product mod n has to be some multiple of that factor. And because you want to find a subsequence that has mod 1, that means that we can't include any numbers that have a GCD of like n greater than 1. Because if we did, then our product would have to be divisible by that GCD. And unless the GCD is 1, then we can never include it. So that's the first step. And so after doing a step, we get like some like result, which is just like the product of these numbers we currently have. And it's possible that if the result itself is 1, then we obviously just stop there because that's a valid answer. And it's also the largest answer. But if the answer is not, if the product is not 1 mod n, then we can actually remove one number and make it mod n. And that's because if the current product has like a product of A has to exist within the set of numbers. And that means that we can just simply remove A from the set of numbers, and we know the product of the rest of the numbers is going to be 1 mod n, because 1 times A is equal to A. And that's the only like possible way we could have gotten a product of A in the first place. So yeah, that's pretty much what this code does. It's pretty straightforward. It's also, this is probably the best problem in the contest. It's really cute. Okay, problem D. Problem D was kind of weird. I'm gonna say it right now, it was just weird. I don't know how to feel about square root decomp being in a div 2, especially in D. I mean, I guess it's a pretty straightforward application, but also I don't really expect div 2, like most div 2 people, to even be familiar with this concept. There probably exists like a better way to do this that's not n root n, but pretty much I'll just go over the main idea because I believe the main idea is the same thing anyway. So basically, what you do is for a number, like if you were to take any range, notice that within these subsequences, we only care about the frequency of elements. So this means that we can take all the numbers in this range and rearrange them however we want. So this subsequence condition doesn't actually affect the problem at all. So that's the first observation you can get. And then the second observation you can get is you realize that the condition of like the fact that no value occurs strictly more than the ceiling of x over 2 times, that's equivalent to saying you want to arrange all the subsequences, like assign elements in like some sequences in a way that no two elements are adjacent to each other. And so when we think about how like two numbers are adjacent to each other, that means that so if we were to have something like n equals 5, and that means we can have at most like 3 numbers that are the same, because then we could form a checkerboard pattern like ABACA, something like that over there. I don't know if you can see that, but that's just how it works. And so pretty much you make an observation, and then the second and then you realize that basically within a subarray, if the mode occurs less than or equal to like ceiling of x over 2 times, then you can always just put everything into one subsequence, and then you're good. And so that's the first observation, or like the next observation. And I think the last observation you need is to realize that if you have like strictly more than the number of like of the mode that you're allowed to have, the best way to reassign these values is just simply keep them in their own subsequence of length 1. And we can show that this works because of an exchange argument. If you were to take like if you were to have like ABACA, and then you would have like 2 A's, we can't ever put this into less than 3 subsequences, because if we wanted to combine like those two single A's together, we would need to use at least we need to use a B or the C from the longer sequence. But if we were to use one of those numbers from a longer sequence, we would have an extra A in this longer sequence, and would have to form its own little subsequence anyway. And so that's the reason why like this formula over here works. And so from there, the problem pretty much just turns into query the mode within a subarray. And the way I did that was square root decomp. There probably is a better way to do it, but I wasn't aware of one. I just couldn't think of one. But yeah, it's fine. Yeah, so that's A through D. And yeah, that's pretty much it. I'm gonna wait for system tests to see what my final rank is. I really do. I would love 2200. Oh my god, I'm so close. It's so frustrating too, because it's like I could have really easily like just I don't know. It was just really easy to not make that wrong mistake on C, and I was just like a little bit faster on D. Yeah, but I mean, as much as we can complain about something, like a good performance is a good performance. I'm still very happy with how it's turned out, assuming I don't FST. If I FST, then I'm going to be kind of pissed. But yeah, other than that, that's pretty much it. I hope you enjoyed this screencast. Bye. Shoot, how do I turn this off? Okay.